Hello students, next important topic is fuel cell based energy storage system. Fuel cells are invented in 1840 and here fuel cells generate electricity by using oxygen from the air and compressed hydrogen. So hydrogen and oxygen reacts together to produce electricity and also water. So the basic principle of the fuel cell is that it uses hydrogen fuel to produce electricity in a battery like device, and the basic chemical reaction is shown here, that is 2H2 plus O2 gives 2H2O. So here the byproduct is water, and also energy, that is electrical energy, is also released here. So we can say fuel cell vehicle as zero emission vehicles because the byproduct is only water and electrical energy. Now let us see what are the main issues in the fuel cell. So first one is cost. Fuel cells are having a very high cost because the fuel used here is hydrogen, so it has high cost. Then water management is very difficult because the byproduct of this cell reaction is water, so the water management is very difficult. Then cooling, fuel cells liberate more amount of heat, so the cooling is very difficult here. And hydrogen supply, for fuel cells hydrogen is the preferred fuel. We know that hydrogen fuel is very difficult to store and transport. Now let us see the basic principle of hydrogen fuel cell. So the basic principle of fuel cell is the release of energy following a chemical reaction between hydrogen and oxygen. So hydrogen and oxygen reacts together to liberate water and also electrical energy. So here also the three main components are anode, electrolyte and cathode. As anode, hydrogen is used, and as cathode, oxygen is used, and as electrolyte we can use acid or alkali, etc. So here two chemical reactions takes place, and the result is that electric current as well as water or carbon dioxide is created, and by using this electric current we can power the load. So let's see the reactions taking place in a hydrogen based fuel cell. So at anode, I said that at anode hydrogen is used, and as cathode oxygen is used. So at the anode of an acid electrolyte fuel cell, hydrogen gas ionizes. So hydrogen gas ionizes, giving H plus and an electron. Okay, so this acid electrolyte can pass this or permit this hydrogen plus ion, but it is a non-conductor to this electrons. So electrons cannot move towards or pass through this electrolyte, but hydrogen ion, that is H plus ions, is permitted through this electrolyte and can reach cathode, and H plus ions can react with this oxygen. So this electron, that is here hydrogen ionizes to form H plus and electron. So H plus ion move towards the electrolyte, and electrolyte permits the H plus ions towards the cathode, but these electrons are not allowed through the electrolyte. So this electron will move through the load, external circuit connected, to reach the cathode. So H plus ion cannot react with this oxygen. Okay, so H plus ions, only hydrogen will react with this oxygen. So for that H plus ions should accept one electron to become hydrogen. Then only this hydrogen reacts with oxygen in the cathode to form water and electricity. So in the cathode, H plus will accept the electron and it will become hydrogen, and this hydrogen will react with oxygen to form H2O. And also with water, electricity is also produced. So this is the reaction is shown here, that is at anode hydrogen is ionized giving H plus and electron, and this electron will flow through the load to reach this cathode, and hydrogen ion will be permitted by this electrolyte and will reach this cathode, and this hydrogen ion will accept this electron from this load, that is from this anode electron move towards this load and reaches cathode, and this electron will reacts with hydrogen to form this electron will react with H plus ion to form hydrogen, and hydrogen reacts with oxygen to form water and also electricity. To form water. So we can use different electrolytes, that is acid electrolyte, alkaline electrolyte. So many different electrolytes and also many different types of fuel cells are there. We can study in the next class. Okay, thank you.